probably. Okay, so a slope field is a graphical representation of a set of slopes obtained from the differential equation. Okay, so remember that the differential equation is like what we just did with the warm-up today that has a derivative in it. Okay, so what does a derivative tell you? The slope. Okay, so we're basically analyzing the slope at different points. So we have x and y's within our slope. Okay, so blah, 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 let's get started. Okay, so number one, we have our differential equation. So this is basically telling us that the slope is negative x over y. Okay, at each of our points. Okay, so all I'm going to do is I'm going to plug in the x and the y and analyze the slope at each of those spots. Okay, so what is my slope at the point 3, 2? Negative 3 over 2. Easy. Okay, what is the, Go. The slope at negative 1, 3? 1/3. 2 over negative 1 makes negative 2. And negative 2 over negative 2 makes 1. What do we think about that? Everybody good with that? Jared, you got that? What? Might have to put that phone down. Learn something. All right.
Why can't you find slopes and why?
It's just find the slope.
Okay, tell me why. Why can you not find the slopes when y is 0? Right? Because the denominator makes 0, you cannot divide by 0, right? Undefined slope. That's a really big idea. Okay, so remember, if I have an undefined slope, what kind of line are we talking about? Vertical line. Keep that in mind. Okay, so let's talk about the slope field. So this is an example of a slope field. Okay, all this is doing is it's analyzing the slope at each of the different points. Okay, so at the point 1, 1, if I plug 1 into here, I have a slope of negative 1. So I draw this little tiny line with a slope of negative 1. Okay, so let's go up here a little bit higher and talk about this slope. Okay, so this point is what? What's the ordered pair? Yeah, okay, so 1, 2. Okay, so if I take 1, 2 and plug it into my differential equation, what's my slope at that spot? Negative 1/2. Okay, so I'm going to draw a little dash right here with a slope of down 1 over 2. So it's going to be like that. See, I do a little tiny dash with that slope. Okay, let's talk about 2, 2. What is the slope at 2, 2? So negative 2 over 2 makes negative 1. Okay. No, you can get any differential equation. Okay, so this one's going to have a slope of negative 1, a little. There we go. Okay, so maybe we can start doing this a little bit mentally, yes? Okay, so this point is 1, 3. What would my slope be at 1, 3? Negative 1/3, so that would go like that-ish. Okay, this one is 2, 3, 2, 3. What's the slope at 2, 3? Negative 2/3. It's a little less steep. Down 1 over 3. Oh yeah, I drew that totally wrong, you guys. My bad.
So it like really matters.
Down 1 over 3. There we go. Huh? Okay, so 3, 3. What's my slope at 3, 3? Negative 1. Okay, let's go this way into this quadrant. None of these are drawn. So this point is negative 1, 1. What's the slope at negative 1, 1? No, they give you the slope field. So 1. Everybody say 1?
Yeah.
Right, Matt? Is that what your phone says?
So it's just the opposite. What's it called?
Yeah, it is actually.
Is it
Okay.
always true to that though?
Not always. Because you could have like a differential equation that was like negative x plus 5 over y, where it's totally different.
But in this case, it's just.
In this case, yes. Okay, so, okay, do you want to just kind of go with that then? So this one would kind of be like that. This one would be a little steeper. Like that. Okay, let's talk about the y-axis. What are all the slopes on the y-axis? So remember the x value is 0 there. So if I plug 0 in, what's my slope for all the zeros? 0. So all of the points on the y-axis are 0. Technically not on the x-axis though, right? So can't divide by 0. Okay, so over here, this one would be like there.
Pretty much like the same thing, just like the zero side.
Exactly, right. Yeah, so what does it kind of look like this is creating? It kind of looks like a circle, right? You see how that slope field kind of generates a circle? Okay, now I'm going to read you the definition of how you draw a function within a slope field. Okay, so it says, starting with the point, okay, whatever the point is, this time it's going to be 0, -3. We're going to follow the flow of the slopes to sketch the solution curve containing the point 0, -3. Your graph should be parallel to the slope lines and look like an average of the slopes wherever the line goes between. Oh.
Yeah, we have 0, 1.
Oh,
And you're dead.
weird.
And where 0, 1 is down there. Yeah.
Okay. Well, we can use whatever ones you guys want to use, doesn't matter. Okay, but here's a big piece right here. Your solution curve must represent a function. Is a circle a function? No. Okay, so we could only use like the top half of the circle or the bottom half of the circle for this scenario. Okay, it also must be on an open interval. Okay, so an open interval means that you have to have like a hole, or it could go to like infinity. You cannot go between 2 points. So I can't just say it looks like starts at 2, 0, and goes here and comes back down to another point. Those are going to be open circles, okay, which is going to make sense because what is the slope at the x-axis?
Undefined.
Yeah, undefined. Remember we wrote that? Hold on. Wait for it. There it is. It's undefined. Okay, so what point do you guys want to use? What does yours say? 0? Negative?
No, 0, 1.
Oh, 0, 1. Okay, so 0, 1 would be up 1 unit, right? Okay, let me draw this in like blue so it's more obvious. Okay, so if I kind of follow the slope fields, it's going to look like this. And basically, every time we get to the x-axis, we're going to have these little holes. It's not a great drawing, but it works. Yeah, they would be at -1, positive. Yeah. Okay. Let's do another one. What did they give you more points? What are your other points? -1 and +1. Okay, so let's do -1, +1. So that's right here, right? Okay, so that flow is going to be like. You see that? So I'm basically drawing. What am I drawing? I'm drawing semicircles. Yeah, we're drawing semicircles. What? The slope field on the test is not the same as this one.
What is it again?
Okay. Did they give me any other points? Did I go through all the points that they
0,
listed?
-3.
Oh, 0, -3. Oh, it is on there. 0, -3. Okay, 0, -3 is down here. So this one would be like. I don't know why this is hard for me to draw a straight line. To like go slow and sketch it.
Yeah.
I mean, it doesn't have to be perfect. You'll get the general curve. Okay, so the next part of this takes us through what we did in A1. So going back and figuring out what exactly the general solution is of this. Okay, so let's do our differential equation solving and figure out exactly what the equation could be. Okay, so how do I start by solving this differential equation? Multiply by dx. Let's do there, so dx. So those cancel, so I have dy equals negative x over y dx. Okay, so then I want my x's all on one side, my y's all on the other. So what should I do? Multiply by y. So I'm going to have y dy equals negative x dx. Okay, so now all y's are on one side, all the x's are on the other. Now what? Integrate, good. Okay, so what's the integral of y? What?
1.
That's the derivative.
Oh, crap. Y squared.
1/2 y squared. What is the integral of negative x? Negative 1/2 x squared. And then I always say plus c when I integrate the x side. Okay, so now I'm solving for the y. What would I do next? Multiply by 2 or divide by half. So I'm going to say y squared is equal to negative x squared plus c. So notice that I did not distribute the 2 to the c. It's still a constant, exactly. I'm not going to make this harder than it needs to be. Okay, what's my last step here? Square root it. Okay. Yes, I am. I'm going to keep it underneath. Yes. Yep. Because it's all a quantity, and when I square both sides, I have to keep it together. So I am going to add a plus or minus, right? Because I don't know if this is a positive square root or a negative. Okay, which makes sense with my semicircles, right? The positive was the top half of those semicircles, and the negative was the lower half. So it depends on which point I'm going to go through. Okay, so my two scenarios are a square root of negative x squared plus c, or negative x squared plus c. Okay, so now this part takes me through the point passing through 0, 1. So what do I do for this? Solve for c, so I'm plugging in 1 into the y, so I got 1 equals. Now if I have 1 for my y value, which of the square roots am I going to use? The positive or the negative? The positive, right? So whatever my y value is tells me which root I'm using. So
is this like basically talking about like positive, negative? This one about
yeah,
just like
yeah, exactly. Okay, so then I just solve this. So square both sides, so I still have 1 equals 0 plus c. So what's my c value? 1. Okay, so my particular solution is negative x squared plus 1, x square root of that. Because it's in the point, 0, 1. From the point.
And it's not plus or minus 1.
Right, because you can't use plus or minus, because it would be impossible for the square root, the negative square root to equal positive, or excuse me, yeah, I said that right. The negative square root to equal a positive 1. That would be impossible to be true.
So then,
You see what I'm saying?
plug the points in your solid.
You can't have a negative square root of some number equaling a positive number. That can't happen.
Plug the points in your solid.
Right, yes.
So what would I consider the square root?
The square root of a negative number is imaginary, an I. Okay, so if I plug in 0, negative 3, okay, negative 3 being my y, so I have negative 3 equals, so now am I using the positive or the negative root? Negative root. Negative square root of negative 0 squared plus c. Of course we did. Because the y is negative. See how I have a negative 3? That tells me I use a negative root. Okay, so to solve this, my negatives cancel on both sides. Okay, and then to get rid of the square root, I square both sides. So I got 9 equals 0 plus c, so we all agree that the c value is 9. There we go. So my equation is going to be negative x squared plus 9. That's pretty much the gist of all this, guys.
We're not finishing the rest of the notes.
Oh, we can. Yeah, we can still do it. It's good to have one more practice, don't you think? I mean, it's up to you guys. It's not new information. It might help you pat down the concrete to fully get it. I mean, it is simple.
Can we do number 5?
Okay, how about we just do number 5?
Alright.
Actually, the other two are just multiple choice also, so we could finish this. This one is easier than the last one. Okay, for number 5, notice that my differential equation is just 1 over y. So basically, I'm like analyzing all the different slopes for the different y's. I don't really care about the x's. So like, yeah, so if I have all the y values of 0, what do I know? All undefined. What about when all of my y's are 1? It's all 1. So I can just be like, slope of 1, slope of 1, slope of 1. Okay, and then when my y's are 2, what's my slope? 1/2, so it's a little bit flatter.
How do you know like which way to go?
Up 1 over 2?
Marks go?
Up 1 over 2? What do you mean the tick marks? Those are just points.
Like, 'cause these ones go this way and these ones go this way. But then on these ones they all go this way.
It comes from your differential equation.
These ones must have been like negative.
Yep.
They have like 3.
1/3, yep. So at 3, we're looking at 1/3.
I feel like my lines are horrible. Like y'all.
Yeah, it's hard to tell. Especially when you get to like 1/6 versus 1/20th. Like, that's pretty hard to tell. Okay, when y is -1, my slope is -1, right? When my slope is -2, my slope is -1/2. Okay, and when my slope is -3, we get -1/3. Okay, so let's draw the particular function through -2, -1. So if I go -2, -1, that's this point down here in the 4th quadrant. Okay, so if I follow my slope field, basically I know that the closer I get to the x-axis, the more vertical it is. And as soon as I get to the x-axis, it's like almost vertical, but I have to draw the hole there because it's technically undefined. So I kind of like draw that. This is gonna come out like that ish. Wasn't great. No, yeah, I wouldn't expect your slope to be perfect, but your general shape should be pretty you know, like I should be able to tell if you're drawing a parabola or like a John Travolta or something like
Why
that.
did we? So we hit -2.
What?
Oh, never mind. Down.
Okay, so let's do it off of 2, 2. So off of 2, 2, that's right here, up here in the 1st quadrant. So this one is going to be like, let's see, and then levels out. So what kind of graphs am I drawing? Sideways parabolas, which is which function? Square roots. Okay, so that means that when I solve my differential equation, that I should have square roots. Yes. At 2, 2? Because they C and B, they give you the points to use. Y on the x-axis. Oh, because if you plug in, let's say we're analyzing the point 1, 0, okay, and you look at the differential equation 1 over y. If I plug 0 into the y value, I get 1 over 0, and that's undefined. So that's why I'm drawing a hole at all of the y values of 0. Exactly, you cannot divide by 0. Yep. Okay, so let's go ahead and solve this. Can I do this pretty quickly? Okay, so I'm dealing with 1 over y is equal to my derivative. I'm just going to multiply my y to the other side and go. I'm going to be a little sloppy here. D dy. I knew that I was multiplying both sides by dx, so can I say 1 dx? Do you see what I did there? Without showing my work. Did I go too fast?
Yeah, you might as well just go.
Okay, my bad.
That was just fine.
Sorry. Okay, so dy, the derivative of y is dy dx, right? Okay, so if I multiply both sides by dx, I have dy equals 1 over y dx. Follow there?
Yep.
Now I have to get my y to the other side, so I'm just going to multiply it to the other side. So I get y dy equals 1 dx. Good there?
Why are you putting
Because it's easier if I have nothing there. What's the integral of nothing? What's the integral of 1? That makes sense, right? That's why I keep it there. I always keep a placeholder. Okay, so now we integrate. So what's the integral of y? The integral of 1 and plus c. So then to solve for y, I multiply by 2. So I get 2x plus c. And then I square root. So I have a plus or minus scenario here, which would make sense in terms of my slope field. We've got the top version for the positive, and the red would be like a negative scenario. Okay, so let's go ahead and find the actual equation. So starting at -2, -1, I would have -1. So which scenario am I using? Am I using the positive square root or the negative square root? Good, so negative. So square root, I'm going to plug -2 into the x for my point. So the negatives cancel, I square both sides, I basically get 1 equals -4 plus c. So my c value is 5. So I would write at -2, -1, my equation is y equals -2x plus 5. Okay, so if I quickly do 2, 2, I would say 2 is equal to, am I going to use positive or negative on my square root here? Positive. So I have 2 times 2 plus c. I square both sides, so I have 4 equals 4 plus c. So this one...
Excuse the interruption. I need the following students to report to the main office. Gabe Beal, Julie Burnett, Ethan Carter, Brendan Clarkson, Brianne Davis, Stephen Evenson, Marissa Heath, Colby Glasgow, Dominic Rollet, Gabe Crease, Mara Coombs, Tyler Monlux, Mariah Morgan, Anders Nordstrom, Leanne Hippenich, Ben Prescott, Zach Smith,
Good.
Jocelyn Sprague, Sarah Sullivan, Jackson Thorne, Hayden Best, Ethan Weirda, Lucas Williams, Kayla Wynn, Kayla Young, Abby Cady, Emma Funk, Madison Krieger, Sammy Jo Moreland, Michaela Johnston, Kendra Dansky, Wyatt Schott, and Michaela Sutton. Thank you.
just when you thought it was over?
Nuh-uh.
I don't know.
It seemed like a bunch of soft.
All the people who are getting held back. Okay, so number 6, do you guys want to do this one real quick?
No.
No.
It's just a multiple choice.
Yes, please.
No. Yes.
Stop.
Yes.
Do you want me to tell you what your assignment is and then do it to make you feel better? You have 1 through 11. There you go. Okay, so number 6 is asking you to figure out which one is the differential equation. So to figure this out, you basically pick a point, make a decision about what the slope is, and see which equation works. So I started out by analyzing the point 0, 0. So what does the slope look like at 0, 0? And it doesn't have to be exact, but we know it's positive, and it looks like about positive 1. Okay, so basically I'm trying to figure out which one of these is the correct differential equation, so this is like a multiple choice question. Just from that point, I can say, well, it's not A, because if I plug 0 in, I would get 0. It's not B for the same exact reason. 0 minus 0 is not 1. Okay, I could do 1 minus 0, and that's 1, so D could work, and E could work also. Okay, so now if I pick another point, what other point might work? Where we can tell the difference between D and E. 1, 2. So 1, 2 is this spot right here. 1, 2. I would say this slope looks like, I would say maybe like 3, because it kind of looks like it's steeper the higher you go. Okay, so let's see which one would work for this. If I plug in 2 for D, I would have 1 plus 2, which is 5. We said 3.
Wait,
I would say that's not bad.
Oh, I see.
Yeah, because I'm plugging the y value in, right? So I'm using the y. So I think this could be 5. I don't know exactly what it is.
Yeah.
But let's check if it's this one. If I plug in 1 into here, this is 1 plus 1, which makes 2. I think that this slope is definitely bigger than 2, because I think this one would be 2. So I would say it's not that one. It's gotta be. Okay.
Integrate E, you get X cubed.
Yeah, and it's a John Travolta rate.
So, that's E. You integrate base.
Yeah, but also if you integrate y, it would be like a sideways John Travolta.
So, I know this.
Oh wait, are you thinking about? But integrating would give you.
Original equation.
Oh yeah. Let's see.
Creative writing.
Oh. Sorry, I didn't read like 5 words.
You can't just integrate this straight. Well, I guess you can. Yeah, you guys could start on your tests. I see what you're saying, Nick. It's under there. I'm gonna give you a reason why, but just not right now. Hang on to that question. Yep. This one, by the way, is B.
My email literally won't work. Watch.
Thanks.
Okay, so there's your guys' assignment. You need to do 1 through 11.
I'll do it when I get home.